Hey, what's going on, guys? CodeMonkeyGames here. A quick update on WukongJS engine development progress. So I'm porting my C version of Wukong to JavaScript, and at the moment I've ported the mode generator completely. And well, obviously I'm going to be improving this mode generator compared to the state of what it was in its initial C version, just to make it faster and more reliable. But at the moment, what is interesting to us is what would be the speed of the perf test running at depth 3 in different environments. So I would be testing this in Firefox browser, in Chrome browser, and then as a backend script within the Node.js. So without further ado, let's actually see what happens. So for those of you who's not aware of what the perf test is, it's the way how one can make sure that his move generator is bug-free by comparing the number of overall traversed nodes with existing values for current given position or another set of specific positions. And here we have 9.855, so almost 10 seconds. Well, also bearing in mind that my video recording software is working now, it slows down the process for about 2 seconds, but still the relative difference between the time taken would be seen really quite nicely. So the next thing to consider would be the same task but already in the Chrome browser, and here it goes much faster. So I'm not sure what the value would be. Yeah, so here it gives like 7 seconds, so that was 9, almost 10. Here it's like almost like 6 and almost 7. Well, if I don't run my video recording software, I just want to say the Chrome is running literally 2 times faster compared to Firefox. That's it. Obviously, if we just run this several times, the values won't be the same every time. Yeah, it kind of depends on. So it might be more or less. But anyway, Chrome is kind of 2 times faster than Firefox, and as according to this article, like JavaScript chess engine in Chrome, we see that, for example, yeah, this Chrome V8 engine is a core component of the popular NodeJS. So this is the JavaScript engine that is used in Chrome browser. So now finally, in order to run this JavaScript code as a backend script, we can use NodeJS. Don't get confused by this Linux 64. That's just because I'm on Linux, and this site shows me the Linux version of Node.js. If you're on Windows or Mac, you should see like download for Windows, download for Mac, etc. So you can just download this Node.js here, and there is the only binary executable that you don't really need to install. You can just run it via command as a command line tool and pass the engine name as a parameter. So you don't even need to install it system-wide to try this test what am I doing here. But obviously installing in a normal way is also a good idea. So here I have so here I'm now running the same engine as the backend script. And by the way, if you're interested, yeah, and here we have 4 seconds, so it's even kind of 2 seconds faster compared to Chrome browser. Again, like if you run this a couple more times, the value might be a little bit different, but the relative, yes, now it goes even a little bit faster, but the relative difference is seen quite pretty nicely. So if you're interested, like how on earth the same piece of JavaScript code can run both in web browser and as a backend script, feel free to watch the previous video within this playlist that is describing the techniques I've used. And now at the very end of this video, I just want to quickly run through the source code that's dedicated to my subscribers, has been following my just programming tutorials. So just to give you an idea what we currently have here in JavaScript version of Wukong and what am I supposed to be doing next, and what kind of experiments are we about to make here. And obviously I will announce some videos that will be showcasing and those experiments and highlighting the most important parts within them. So I have well, first of all, the biggest job probably that I've done. I have ported the mode generator code to my JavaScript chessboard library, but that had but there I didn't change the variable names, the style of variables, so they were in Python style, like lower cases, underscore, lower cases. But I really want this code to be to look like it's a real JavaScript. So I'm using the camel case style code style here to represent either the function names or variable names. Well, the command style is still the same, so I'm kind of trying to command every single line of code as before, but all the variables has been renamed here, so it's more looks like a JavaScript now. Yeah, so here I'm just I've already started working on implementing piece lists, which is an interesting topic to consider. But before this, another little update here is that now I'm actually I've placed the variables that regards to the specific part of an engine from above, from the global definitions down to the section that is responsible for the corresponding for corresponding methods or functions. So everything that describes the chessboard, squares, and things like that is available in the top of the source code. But then, well, here is the pseudo-random number generator and Zobrist key generator as well that I've been mentioning in the previous videos. But yeah, here's the board. But yeah, so here when it comes to mood generation, we need this to it's not two, it's actually like 1, 2, 3, 4, 5 variables. So we have the piece move offsets that are used only within the mood generator, so I think it's quite pretty logical to place them within the mood generator section. Again, like I really don't like to split the source code into multiple files, because when you're reading someone else's code, it's quite pretty, I don't know, to me personally, it's complicated to navigate through different files when you have no idea where the function definition or method or class definition might be, where on earth that might be. So say you just finding some sort of a variable within the mood generator and you really don't know where it's being defined. So that's the reason why I prefer to keep the single source file, so it's extremely easy to find which variable is defined, where that happens for the first time, and things like that. So to improve this approach even more, again, like I decided to put the variables that regards to mood generator in particular here in the mood generator section. So piece of sets is quite pretty self-explanatory for those of you who has been following my hexadecimal 88 mood generator tutorial series here on Chess Programming channel. Castling rights array serves the purpose of keeping track of the fact whether the kings or rooks actually moved from their initial squares or not. So that's another little trick here. And yeah, then just my casual moving coding functions to make sure that we encode the move into a single integer to speed up the performance of the mood generator. The square attack function. So all pretty standard stuff. Generate moves. Again, like I've changed the style of variables everywhere it was possible. So now it looks like a real JavaScript here. Well, even though it's not JavaScript-ish, let's say, when it comes to making things like parse fen, so I still keep the algorithms that I've used in C programming language, but I think that is even better, because in this case you can reuse the code in whatever language without relying on JavaScript specifics, let's say. So another one of the most weird things that I had in my original Wukong engine, I was copying the current board state before making a move, and then if the move is illegal, I was taken back by restoring the board position state variables back from its copies. And apart from adding piece list, this is one of the first things that I would like to change to implement actually a full-blown take back function. That would be a challenge to pass the performance test again with those updates, but hopefully that would give me a better performance. So as soon as I implement this kind of things. I would be happy to make another video showcasing the difference between the current version and the version that would be involving the take back function and no copy make approach anymore, but just make, move, and take back regularly like normal people do. And also adding piece lists. I'll give you a brief idea of what the piece lists are now and how one can make use of them. But before that, so here in the input and output section, I brought all the piece characters in code, and as well as the Castellan bits down below, because this is the exact place where we actually we're making use of this kind of variables. So here, this is where it happens. So we're parsing the FEN. Well, probably Unicode pieces is a little bit misplaced, because it would be better to use them above the print board. Yeah, so probably I need to put it above the print board. Okay, but anyway, yeah, and the fact that I was mentioning like C style code. So here I'm just using the ASCII codes for these characters, using this character code add method. So it's really good. Like I see like C programming language style here. So probably in JavaScript we could make it in a bit more fancy way, but again, I could just try to make when it comes to working with some core things like files and ranks and calculating extracting file and rank from, in this case, from the peasant square. I really want to make this code sharing the same algorithms regardless of programming languages. Okay, oh, I just have the print board function here. Yeah, okay, so input and output. Yeah, that's the reason why actually I did put this Unicode pieces here. Yeah, now it gets clear. I just already forgot about that. So yeah, and then here is the perf test. And again, like this weird stuff, we just copying the board position and state variables and then restoring it back when we actually need to take the move back. So this is one of the first things that I'm supposed to be changing here in the source code. So now it works just as the proof of concept. And another thing would be to add piece lists. So let me just navigate quickly to the generate moves function. Oh, sorry, still using this Python style, so let's use camel case here. So generate moves. If you have a look at this line, you see that we actually make a loop over all of the board squares, and then we need to distinguish whether the square is actually on board or not. So this kind of takes time. And instead, what we could have done instead, so we could have keep so-called piece list, which is the data structure where on the one hand we have all the pieces. So there might be up to 10 pieces of each type, and every single piece is and there is a square associated with every single piece if this piece is available on a chessboard. So instead of looping over the squares, we would be able to loop only over the existing pieces, and we can instantly get the source square for every single piece by simple lookup. Well, we actually do this by lookup here as well, assuming the array-based board representation. But again, like here we just looping over too many squares, which is, it really slows down the performance. And according to Richard Olbert, also known as a Bluefield software, he mentioned in his WiseChess engine that piece list gives at least 30% of a performance gain. So I think that this is quite pretty nice feature to add. And as soon as I implement piece lists, I'll show you the difference regarding the performance. So we'll run the perf test again to see how faster it would be after adding piece lists, and also implementing the take back function. I'm also interested in whether that would actually affect the performance or not. So probably we'll make a couple of tests just to make sure that we know all the tiny little details of what in particular influences the performance and how exactly. And also I'll probably when I would be having the particular implementation of piece lists, I did this once before, but just really need to refresh my memory. So I would be explaining on how that works when I implement that, not now. And I hope that the implementation of pistless would be crystal clear for you guys. So in case if you would be having, if you're working not with a bitboard representation like I did in my BBC Chess Engine tutorial series, but with the array based, like either hexadecimal 88 or 120 is also acceptable. So in this case, pasteless is a really nice thing to consider. We're not gonna be using them only in the mode generator, but also we're gonna be using pasteless within the evaluation function, which significantly speeds up the search, because again, like if we don't have that, we need within the search we need to make this move again. So we're kind of making this all this loop kind of twice. First in order to generate moves, and second time in order to again like associate every piece with a particular square to evaluate the positional square, to evaluate the positional score for every single piece. Well, okay guys, so I think this is it from my side, and again, like it's very interesting for me personally to see the difference on how this little tiny JavaScript chess engine performs within different environments. This is really quite exciting for me. So if you don't want to install NodeJS, you can at very least try to test this in your browsers. And again, like if you want to be watching this video, let's say, I don't know, after several months of after it would be published, the source code would change quite pretty a lot. But I think that, well, most likely I will provide some API to run the perf test, so regardless of the development state, you would actually be able to run this perf test and to see the result. If you would be having any issues with running this perf test, please let me know in the commentaries and I will help you to resolve this issue. This is it from my side, guys. See you next time. Until then, and take care.